Hello everyone, follow through as I answer question 3 from a 2024 GCE Mathematics paper 2. The question has two parts, A and B. Starting with A, express 2 over x plus 2 minus 5 over 3x minus 1 as a single fraction in its simplest form. 3 marks for this part. So to solve the expression given, we are going to solve it the same way we solve fractions with numbers. So on A, we have 2 over x plus 2 minus 5 over 3x minus 1. So the denominators are expressions, so we are going to find the common denominator in terms of these expressions. So we show that they are multiplying, so this will be x plus 2 in brackets multiplying with the 3x minus 1 in brackets. So this here is the common denominator. We now divide the denominators into the common denominator. So x plus 2 into x plus 2, 3x minus 1. So x plus 2 simplifies with x plus 2, leaving us with 3x minus 1. So 2 is multiplying with 3x minus 1. Then minus 5, 3x minus 1 into x plus 2, 3x minus 1. So there we get x plus 2 because 3x minus 1 simplifies with 3x minus 1. So we write x plus 2 in brackets. So multiplying and simplifying what we have on top there, 2 times 3x gives 6x. Then 2 times negative 1, that gives negative 2. Then negative 5 times x, that gives negative 5x. Negative 5 times positive 2, we get minus 10. Then all this is over x plus 2, 3x minus 1. Simplifying on top, 6x will subtract with 5x, then negative 2 will subtract with 10. And then this will be over x plus 2 in brackets 3x minus 1. Simplifying what we have on top, 6x minus 5x, this gives x. Then negative 2 minus 10, we get negative 12. So this will be over x plus 2, 3x minus 1. So we have expressed the expression which was given as a single fraction. Moving on to 3b, in the following diagram, OA vector is equal to A vector, OB vector is equal to B vector, and AX to AB is equal to 2 to 3. Roman numeral 1, express in terms of A vector and OB vector on AB vector. So on this part we want to find the vector AB in terms of A vector and OB vector. 1 mark for that. So on B, Roman numeral 1, A, on this part, to get the vector AB, we will consider the following directions: AO vector plus OB vector. So AO vector plus O to B vector. So this will equal to, on AO vector, this is the opposite of OA vector. So we apply a negative to A vector, then plus OB vector, this is B vector. Then AB vector can be written as follows. We can start with B vector, then write minus A vector. So that is the solution on AB vector. Moving on to B. On B, we want to find the vector XB. Now, if you take note of the information that was given, it is given that AX to AB is 2 to 3. So this simply means AX is 2 out of 3 of AB. Okay, so now, since we want to get the vector XB, so XB will equal to 1. So since AX is taking 2, so XB will take 1 out of 3 of vector AB. substituting what we have on AB vector, so this will equal to 1 over 3 of, we found B vector minus A vector on AB vector. We can multiply this. XB will be written as follows. So this is equal to 1 over 3 of B vector minus 1 over 3 of A vector. So this here is the solution on B, Roman numeral 1. Moving on to C. On C, we want to get the vector XO. So to get this vector, we will consider the directions XB vector, then plus BO vector. So we got XB on B, and BO vector is just the opposite of OB vector. XO vector is going to equal to, XB is 1 over 3 B vector minus 1 over 3 A vector. Then BO vector is just minus B vector. So we collect like terms here. This is going to be XO vector equal to 1 over 3 B vector minus B vector, then minus 1 over 3 A vector. XO vector is going to equal to, so on 1 over 3 B vector minus B vector, we can get the common denominator, which is 3, and 3 into 3 is 1 times 1 B vector, that gives B vector. Then on B vector, we can introduce over 1 there, and 1 into 3 is 3 times negative B vector, that gives a negative 3 B vector. Then this is going to be minus 1 over 3 A vector. So on top there, B vector minus 3B vector gives negative 2 B vector. So XO vector is equal to negative 2 B vector over 3, then minus 1 over 3 A vector. So this is what we get on XO vector. Moving on to Roman numeral 2. Given also that OY vector is equal to 3OX vector, show that BY vector is equal to A vector plus B vector. So to show that BY vector is equal to A vector plus B vector, we start by finding OY vector. So Roman numeral 2, OY vector is equal to 3 times OX vector. Now, OX vector is the negative of XO. We got XO on Roman numeral 1C, so we are simply going to multiply what we got by negative to get the OX vector. So OY vector is equal to 3 times, so this will give us positive 2B vector over 3 plus 1 over 3 A vector. So it is the negative of XO vector. In brackets, 2 over 3 B vector, then plus 1 over 3 A vector. Multiplying 3 times what is in brackets, this gives OY vector equal to, so 3 times 2 over 3 B vector, this gives 2 B vector, then plus 3 times 1 over 3 A vector, that gives A vector. To show that vector BY is equal to A vector plus B vector, this will involve OY vector. So the directions we are going to take are as follows. BY vector is equal to, so we'll use the direction BO vector, then plus OY vector. So BY vector is equal to, BO vector is the negative of OB, so negative B vector, then plus OY vector, we found 2B vector plus A vector. So now we can add negative b vector plus 2b vector, so that will give us b vector. So b y vector is equal to b vector plus a vector, which can also be written as follows: by vector is equal to a vector plus b vector, hence shown. Alright, so thank you so much for following through as I solved this question 3 from a 2024 GCE Mathematics paper 2.